Hello, good morning, guys. I'm not sure whether you'll see this during the morning or you'll see this during the day, but anyway, greetings. All right. Let me start here. Right, so if my memory serves me well, I sent you the notes, some notes on periodic functions. This is just a warm-up of the next chapter, which is Fourier series. But we perform Fourier series given that a function is periodic. That is why I thought that maybe we should start by talking about periodic functions, which I think you're familiar with, probably have seen them at high school. So you remember that in trigonometry you used to calculate the period of a sine function, a cosine function, and so on. And in general, an easy definition, if you say a function is periodic, it means that a function repeats itself. The y values of a function repeats themselves after some interval, after some units. So for instance, look at the first definition here. I wrote that a function is said to be periodic if there is a positive number such that f of t is the same as f of t plus alpha. That is, if the values are repeated at regular intervals of the variable t or x or whatever the case may be. So that interval for which the function repeats itself is called a period of f of t. So the graph of such function is obtained by repeating the graph in that interval. So an example that I wrote here is this. Look at this graph here. It starts, the y value f of t here is 0. It goes up, f of t is 2, and it comes back to 0 here at t equal to 6. So look at the first cycle. From 0 up to 6, it has this behavior. And after 6 units, it will start afresh. It will go up to 8 and come back to 12. So can you see this cycle here? From here to there is the same as from here to there. So it means if this will continue like this, it will start from here to from 12, go up to 14, and go back, say, in 18, if this was continued. So if you look at it here, it's like this. There's a function here. 0 is here, and the function comes back at 0. So it means after 6 units, the function is repeating itself. So this point here, where f of t is 0, is repeating itself at t equal to 6. And the same point at t equal to 6 is repeating itself at t equal to 12. Probably to do the same thing at t equal to 18 here. So you already see that the graph here repeats itself after 6 units. Same thing applies. Look at it at 2, it is here on top. At 8, it is here on top. Also at 14, it's here on top. So 2, from 2 to 8 is 6 units. From 8 to 14 is 6 units. So it means this graph repeats itself after every 6 units. So it means, hence, the period of this graph is 6. Let me call it alpha, 6. So mathematically, we can write it like this. F of t is equal to f of t plus 6, which means that this 6 is a period of f of t. So it means the graph repeats itself, or the function repeats itself after every 6 units. So this is what we mean. So just to summarize things, when we say a function is periodic, we check where the function is not repeating itself. If it is repeating itself, we have to find out how many units does it repeat itself. So we see that in this case, the function, this point, y is equal to 0 is here at t equal to 0. The point y equal to 0 is here at 6. The point y equal to 0 is here at 12. Same thing applies. This higher point is here at 2, here at 8, here at 14. So it means the graph keeps on repeating itself after 6 units. Hence, the period of this function is 6. If you go to this one, this looks familiar. This should look familiar to you. You sketched this at primary school, if I'm not mistaken. So look at this graph here. It is here at 0. It goes up. Okay, it's at 0, but it changes the direction now. So it is not yet repeating itself. And then it arrives here. It has completed the full cycle here. After how many units? From 0 up to 2 pi units. And then from here, it starts the same thing. Goes up to 1, goes back to 0, goes down to -1, and back at 4 pi. So this, for instance, if you take this point that has a behavior of starting from 0 going up is somewhere here at 2 pi. So this behavior from 0 going upward is repeated here at t equal to 2 pi. And probably that behavior will be repeated here as well after 4 pi. So it means that this function has a period 2 pi because it keeps repeating itself after 2 pi units. Same thing applies if you take the highest point here. Look at this point, 1. This is pi over 2 is to 1. Same point is repeated here at t equal to 5 pi over 2. So from pi over 2 to 5 pi over 2, if you take the difference, say 5 pi over 2 minus pi over 2, I think it's 2 pi. Same thing applies if you take this point and that point. Then the difference is 2 pi. So it means this function keeps on repeating itself after 2 pi units. You said this at high school that a sine function repeats itself after 360 degrees. So it means that this function is periodic with the period 2 pi. And so I suppose that you see what is the meaning of periodic function. So I just wanted to remind you, how do you say the function is periodic? You see it by, if it repeats itself, then you check after how many units does it do that. But what I want you to do, what I'm expecting you to do is this. So here I gave you a sketch of a function, and what you need to do is to check after how many units does a function repeat itself. But what I actually want you to do as an exercise here is that I will give you a definition of a function. So f of x is equal to that, and I give you a period of a function. I tell you what is the period of a function. And then I want you to sketch the graph of this function given the period in a given interval. I'm not sure, but I hope those who did pre-tech or ECP, they would have sketched the graphs of piecewise functions. So let's see how to sketch a periodic function. So it's a function, and then you are given the period of that function, and you want to sketch it in a prescribed or in a given interval. So I'll try to sketch it here in front of you in this board here. So let me write down definition of this function here. So it's f of x equal to x for x greater than 0, less than 2, x equal to 3, or x from 2 up until 4. So this is our function. And we are given that the period f of x is equal to f of x plus 4, which means the period of the function is known, it's 4. And we are sketching from -4 up until 8. That is where your sketch would be. So I guess the first thing you need to do is to sketch, label your axis. So your axis would be there. So the first thing is you start sketching the first part, this first part. How do you sketch the first part? You say you take 0, the first value, and substitute here. So if you put 0 here at x, you get 0. So 0, you put it here, you get 0. So it means you are going to have a point 0 is to 0 here. And I'm leaving it open because there's no equal to. It means 0 is not included. So 0, you put 0 here, you get 0. So you've got a point 0 is to 0 here. And I'm leaving it as an open circle because there's no equal to here. It means 0 is not included. Then I'll go to the next point here, which is 2. I'll take 2 and substitute here. And when I do that, 2 substituted here, then I'll get 2. So I'll get, say, 2 here. So I'll have a point 2. When x is 2, y would be 2. So let's say 2. So I'll have a point 2 is to 2, but there's equal to here. So I'll shade this point. Yeah, I'll keep this shaded because of this equal to. It means 2. X equal to 2 is included here. And then what I'll do is that I'll say, how do I move now from this point to the point? It's a straight line. Straight line that will take me from here to here. X is a linear function. So I'm moving from this point to this point using a straight line. So I've sketched the first piece of this function. Again, to repeat, you take the first point, you substitute here. So if x is 0, it means f of x is also 0. So 0 is to 0. If x is 2, it means f of x is equal to 2 as well. So 2 is to 2. But you shade this point because of that equal to. Then you join the points by putting a straight line, because this is a straight line that has a positive gradient. It's a straight line going up. Hope you remember that. Now we've sketched the first part. Now we are sketching the second part. So if we were to sketch second part, what we'll do is that we'll take this. If x is 2, what is f of x? Okay, because there's no x here, it means whatever x value is, f of x is 3. So it's constant. 3. So we've got a point 2 is to 3. So which is this point here. Shaded or not shaded because there's no equal to here. So again, if x is 2, f of x is 3 because there's nothing to substitute in there. So it's constant 3. So we've got a point 2 is to 3. So if I put this point, the next one is 4. 4, this 4. 4, when I substitute 4 here, I get 3. So 4 is to 3. So 4 is to 3, it's a point here. And then this point will be shaded. Now I want to move from this point to that point to join this graph. So it's a constant. So the constant would be a constant line like that. Now this is a graph of a function here, a piecewise function here that I've sketched. So for the second graph, I said 2. When I've got x equal to 2, what would be my y value? 3. So 2 is to 3. 2 is to 3. If x is 4, what is my y value? 4. Y value is 3. So 4 is to 3 is here. And then how do I join these points? I join them using a line, straight line. Now we have sketched this part. Now the next thing is to look at these conditions now. What is the period and what interval you sketch? Where do you start? Where do you end? Now we use these two properties. Now, this here, it means the higher we go up to, so it should be x, sorry. Should be x here. So it means when you sketch your graph from -4 up to 8. You sketch but yours now is from 0 to 4. So it means extend it from -4 up to 8. So you using this, using the period that you are given. So what I'll do, I'll try to extend my graph to 8 on the positive side. Okay, I was counting in 2, so let me say 6 here. Let me say 8 here. Stop. Yeah. So how do you extend the graph? When you extend the graph, you extend it use a point by point. So you move every point according to the given period. So the given period is 4. So it means take this point and move it horizontally 4 units. So this point was here. So 4 units from here is here. Same point, but moved 4 units. This point was here at 2. You move it horizontally, but 4 units. So it was at 2. 4 units after 2 is 6. So it should be 6 is 2, 2. And it's still shaded when you move it. And it's still the same line, right? So it should be straight line. So what you do is take this point and say, move it horizontally, but 4 units. It was at 0, so it is now 4. This point, you move it horizontally, how many units? 4 units. It was at 2, so it should go at 6 now. So we have moved this graph. You have moved it here. Now you come back now, you move the other graph, this one. So it was at 2 is to 3. So this point was at 2, at x equal to 2. So it means now you'll move it 4 units because the period is 4. So moving it 4 units, it means you take it from 2 up to 6, but horizontal. It doesn't change the y value, but it moves horizontal like that. It's not shaded, right? So it should be not shaded still. This point is now that. That point was at 4. You'll move it 4 units. It will be now 4 plus 4 is 8, but shaded now. And then the shape is the same. You join in the same way. So we've moved our graph up to 8 now by a periodic repetition. So we are repeating this graph now after 4 units. Now, on the left, we are told to start from -4, but here we started at 0. So we move it to the left as well. Because I was counting with 2's. Let me count with 2's as well. This side. -4. So you move every point 4 units. So you move the original graphs. These are original graphs that you sketched before you consider the period. It's up to you. You can start moving this function. It's up to you, or you start moving that. Let's start moving this function here. This one was at x equal to 0. So it will, if it will move 4 units to the left, it should be here. This point will move 4 units to the left. It should be here. This point will move 4 units to the left. So 4 units is to the left is here. 4 units to the left is here. So this function is like this now, moved 4 units to the left. 4 units to the left. All right, so this function has been moved now. How many units? 4 units to the left, because this point was at 0. Now, if it moves to the left, it will be at -4. This point was at 2. If it moves 4 units to the left, it will be at -2. So we've moved the first function. Now let's move the second piece now. This was at x equal to 2. So it will move 4 units to the left. It will be at x equal to -2. This was at x equal to 4. If it moves 4 units to the left, it will move 4 units. It will be here at 0. And it should go straight. Remember, this was shaded, so it will be still shaded. Right. Now we've sketched this graph from -4 up to 8 in this given interval of x. But what we did was we started by sketching the original graph. So we first sketch this graph, which is that. Then you follow this graph, which is that. Then you move every point 4 units. We move this graph. You move it point by point 4 units to the right. You move this graph. You move point by point 4 units to the right. Then you go and do the same thing to your left. This graph, you move point by point 4 units to the left. And depending on the interval, if I can extend this interval, and say maybe 16. It means we have to go and move here up to 16. So I suppose that is how you sketch a graph of a periodic function and extend it. That is how you extend periodic function. So if you look at this graph, you see this thing repeats itself here. This thing repeats itself there. This thing repeats itself there. This thing repeats itself there. After how many units? After 4 units. Every repetition is after 4 units, which is a period that is given here. So that is number 1 in that exercise that I sent you. Now, which one should I do? Should I do number 2, number 3? I'll take number 3 and try to sketch it now for you. I know that you don't like that because you want to sketch for yourselves now. You can't wait to sketch for yourselves. So let me erase this now. Okay, because you'll have a video, so I don't have to keep these notes as I've recorded. So you'll have to, I don't know, maybe download the video if you can, so on. So let's go to number 3 in the exercise. Number 3 in the exercise, I'm referring to this number 3. This number 3 here. Let me try to do it in front of you. So I made a mistake. I should be using t here. So f of t is equal to let me use x. All right, let me use x. But it could have been anything. X or t, it doesn't matter. Minus x plus 4 from minus 3 up until 0. Then x squared from 0 up until 3. And we're given that f of x plus 6 is equal to f of x, which means that the period is 6 in this case. And you want to sketch from x from minus 9 up until 9. But you'll worry about this later. Your first thing that you need to do is to try and sketch the graph of this function. So let's see. Let's see what is going to happen. All right, so the first thing is you sketch the first piece of a function. So you take minus 3 as value, you substitute here. Minus 3 plus 4. I suppose that is 7, is it? So 7. My value is 7. So at x equal to minus 3. So minus 3 is to 7. And it's a shaded point. Yeah, it's a shaded point. Shaded because there's that equal to. So it's x equal to minus 3. Then next thing you say when x is equal to 0. X is 0. What is the y value? 0, substitute 0 here. You get minus 0 plus 4. You get 4. So 0 is to 4. Then you join these 2 points. Straight line. So it should be straight line. So because this is a straight line, minus x plus 4 straight line, that is having a negative gradient. So it should be decreasing. Should be decreasing. So we have sketched this part. So you just substitute the first point, you plot the point, you put the point, shade it if there's an equal to. Put the second one, second x value, you get a 4, you don't shade it because it's not, there is no equal to. So you have sketched the first part. Second part, You take 0 and substitute here, you get 0. So it's a point 0 is to 0. Yeah. The next part is 3. When you put 3 here, you get, suppose you get 9. 3 is to 9. And how do you go from here to here? It's a parabola, x squared. It's a curve, so you can't go straight. So it means you go with a curve like that. So it should be a curve, you know, a curve of parabola, x squared. I'm sorry, my sketch is a bit ugly, but you see what I'm trying to do. So I want to go with the curve, but here I go with the line, the straight line. I should go with the straight line. Yeah, I'll go with the curve. But since you'll be writing in a smooth surface, please make sure this is straight. Make sure this is curved. It's like a parabola. Oh, sorry, this is shaded. Shaded because that when you put 0 here, you get 0 including 0. So this is shaded, but that is open, not shaded. So you've sketched this part. Now, what you need to do is to look at the period. The period is 6. So extend your graphs, both of them, 6 units to the right or to the left, depending on the interval. So we ended at 3, so at the maximum here is 9 in the interval. So we can go to the right. Okay, I was counting with 3, so let me continue counting with 3. Say 6, let's say 9. So I'm starting with moving the first graph, 6 units. So if you are from -3, you want to move this point. Same horizontal 6 units, period. From -3, if you count 6 units, -3 plus 6 is -3. So it should be, this +3 should be here. This point should be moved 6 units to the right. Yeah, still at the same horizontal line. This point should be moved. It was at 0. It will move 6 units to the right. It should be here. So same straight line. Yeah, same straight line. Then, so we've moved this. We've moved it 6 units to the right because the period is 6. This point was at -3. If you add 6 to -3, it goes straight to that. This point was at 0. If you add 6 to that, you go straight to that. Now we've moved this graph. We've moved it 6 units to the right. Now what you'll do, you will move now this curve. This was at 6. I mean, this was at x equal to 0. So it will move at 0. So it will move now 6 units. It would be here. Still shaded. This was at 3, at x equal to 3. So it will move horizontally. Yeah. And it should be a curve, like I said, a curve. Right. So there's no need of moving now this further to the right because we were told to aim to sketch up until 9. So we've reached 9. Now what you need to do is to go to the left. To the left, they said you must start from -9. So it means now do the same movement to the left. So start moving this graph, our first graph. This point was at -3. So it will move. So -3, -6. So move 6 units to the left. So -3, -6 should be same point, but yeah, shaded, still shaded. This point was at 0, so it's moving 6 units to the left now. So it will be at -6. It will still be so a straight line. My lines is very ugly. Let me try and correct my line. So it should be a straight line, not this horrible straight line. So this point is here. It should be. Yeah, so I can't sketch this line. It should be a straight line. Right, so this point was moved 6 units to the left, so it was -3. So if you move 6 units to the left, you go to -9. This point was moved from 0. If you go 6 units to the left, you go to -6. So this graph has been moved to the left. Now, this one, let's move it to the left as well. This was at 0, so it will be here now at -6. This point is here now, -6. This point was at 3. If you move 6 units to the left from 3, 3 minus 6 should be -3. Yeah. And how do we move from here to here? It's a curve. It's a curve. So it should be a nice curve, like a parabola, not this kind of a curve. So we stop at -9. We stop here. We can't go further because we're given restriction that our graph is sketched from -9 to 9. So it means you've got a function f of x. You extend it according to the period that is given, which is 6. You extend it from -9 up until 9. I think that is straightforward. That is straightforward. So what we can do to look at this is to try and redo this for ourselves and see if you understand this. And then you can further do number 2 here in a similar way. Number 2 will be much easier than number 3. It's much easier. And then maybe if you want some more exercise on this, I'll send them to you using our WhatsApp group. Otherwise, I think that is all I wanted to say. That is all you have to do for now about sketching periodic functions. So yours is I'm expecting you to be able to sketch these 3 graphs. Sketch a function, extend it in a given interval using a given period. And the next lecture will be on Fourier series, which I will send you a summary of notes. However, in these study notes, everything is explained. Everything is explained. So it's up to you. You can use these notes, or like for instance, this is the second lecture that it will be about Fourier series. So it's up to you. You can use these notes, or you can use my summarized ones. So I try to take these notes and summarize them in an easy way. So I think that's it for now. Yours is true. Try to listen and understand what I was trying to say, and try to sketch these functions for yourselves before the next, because I'll post the next lesson probably tomorrow. So yours is to do this today. So make sure that you go according to my pace, because if I've passed this stage and you're behind, you'll be behind forever. So I think that's it for today. So now I can stop recording. I can stop recording and also leave the meeting. So stop recording.